Welcome to Pod4 Journal Club, where we break down some of the most fascinating new research out there. Today, we're tackling a question that honestly sounds like it's straight out of science fiction, but it's becoming incredibly real. Can an AI actually know what it knows? We're going to dive into a new paper that tries to measure exactly that. Let's get into it. So, let's start with the big question, the one that's really at the heart of this paper. When an AI gives you an answer and says it's 99% sure, should you actually believe it? You know, it's one thing for an AI to be smart, to get the right answer, but it's a whole other level for it to be wise enough to know when it might be wrong. And the stakes here are getting really, really high. As the researchers point out, when we start using AI to help diagnose diseases, manage financial portfolios, or even drive our cars, well, its ability to tell us how sure it is isn't just a cool feature anymore. It's an absolute must-have for safety and for us to actually trust these systems. So, to figure out how to measure this kind of self-awareness, the researchers did something pretty clever. They didn't try to reinvent the wheel. Instead, they turned to a field that's been studying this exact thing for decades: human psychology. First off, we've got to get a key distinction crystal clear. On one hand, you have performance. That's simple, right? Did the AI get the answer right or not? But then there's metacognition, and that's the AI's ability to kind of step back and accurately judge its own performance. It's the difference between just doing something and actually knowing how well you did it. And that brings us to this crucial concept, metacognitive sensitivity. This is really the core skill we're trying to pin down. It's not just about an AI being confident. It's about whether that confidence actually means something. Its confidence should go up when it's right and go down when it's wrong. So how do you measure that? Well, the authors didn't need to cook up a whole new toolkit from scratch. What they did was they adapted the gold standard that neuroscientists had been using for years to measure this exact same thing in humans. That framework is called signal detection theory. Okay, here's an easy way to think about it. Imagine a smoke detector. Its performance is just its ability to tell the difference between actual smoke and, say, burnt toast. Simple enough. But its metacognition would be its ability to know how certain it is about that call. This theory gives us the math to measure both of those things separately. So we don't just see if the AI is right, we see how well it knows it's right. And what's so cool is that this whole complex idea can be boiled down to one key number, the M ratio. Just think of it as a self-awareness score that goes from 0 to 1. A perfect score of 1 means the AI is perfectly calibrated. Its confidence is a perfect reflection of its accuracy. Anything less than 1 shows us there's a gap between what it knows and what it thinks it knows. All right, so that's the framework. Now for the fun part. Let's look at the actual experiments and see how today's big models stack up. The researchers put 3 of the most popular large language models through their paces. We're talking GPT-5, DeepSeek, and Mistral Medium. And they didn't just give them one easy challenge. Nope. They tested them on 3 really different tasks. First, could it figure out if a movie review was positive or negative? Second, could it tell if a sentence came from spoken language versus written text? And a third, kind of tricky one, could it detect if the word "the" had been sneakily removed from a sentence? So the first experiment was all about getting that baseline M ratio score. It was pretty straightforward. For every single task, the AIs had to give their answer, and then, right after, rate how confident they were on a simple scale from 1 to 5. And this chart really just says it all. The main finding is they were actually pretty good. Their M ratio scores were high, some getting close to 0.9, but, and this is key, none of them were perfect. This is some of the first really clear number-based evidence that these models have a real measurable level of self-awareness. But it also tells us there's definitely still room to improve. Okay, so AIs have a decent amount of self-awareness. Got it. But how does that self-awareness hold up when things get a little more stressful? The second experiment introduced a really fascinating twist: risk. So for this round, the researchers changed up the prompt. They basically told the AIs, hey, for this next question, getting this specific answer wrong is a high-risk error. It's a big deal. This whole setup is designed to test whether the models can get more cautious when the cost of failure goes up. And now look at this, because the result is what's so interesting. This table shows something called decision bias. Just focus on the row for GPT-5. When the researchers told it that answer S1 was high risk, its bias shifted way over. It became much more hesitant to pick it. And the exact same thing happened when S2 was the risky one.
The AI basically became more conservative. It started avoiding the risky answer unless it was super certain it was correct.
Now, of course, like any good piece of science, this study has its limits, and the authors are actually very clear about what they didn't cover, which is always great to see.
They're quick to point out that this isn't some final universal benchmark. For one thing, it doesn't really tackle the whole problem of hallucinations, those bizarre moments where an AI is completely wrong but acts 100% confident. It also doesn't get into more complex decisions or how changing things like system prompts or that temperature setting might affect the results. So let's zoom out. What's the big picture here? Why does all this talk about AI metacognition matter so much for how we're all going to be working with these incredibly powerful tools in the future? The authors wrap up with this really powerful statement. As AIs become our co-pilots, our research assistants, and in some cases, our autonomous decision makers, being able to understand and measure their ability to self-assess is, well, it's not just some academic exercise anymore. It's becoming a critical need.
What's great is that this research gives us a clear roadmap for what's next. The next steps are to design even more complicated tests, to figure out how AIs can learn from the confidence signals of others, both humans and other AIs, and ultimately to use these very tools to build AI systems that aren't just smart, but are also wise enough to know what they don't know. Which kind of leaves us with a pretty provocative thought to chew on. If we can actually build AIs that have near-perfect self-knowledge, are we going to reach a point where we start to trust their judgment more than we trust our own? Something to think about. That's all for this Journal Club. Thanks for tuning in.